Hey, Dave Staublin here. We're looking at some number patterns as our intro to sequences and series. And for each of these four sequences, we want to describe the pattern. Where does it start, or what number does it start at? And then how does it change from number to number to number? And then fill in the missing numbers. Okay, so for sequence A, I see that it starts at 4. And then it looks like it's going times 2 each time. So the pattern or the rule would be times 2. So let's finish filling in the numbers, and I'm thinking 64, and then 64 times 2 would be 128, and then let's see, times 2 would be 256. Okay, there's sequence A. All right, let's look at sequence B. It appears that it starts at the number 80, and then looking for a pattern, it looks like it's minus 3 each time. So 71 minus 3 would be 68, minus 3 would be 65, minus 3 would be 62, minus 3 is 59. Perfect. Let's look at number C. It appears that our sequence starts at 4, and this one looks very similar to sequence A. The numbers are all the same, but every other number is odd. So how do we go from 4 to 8? It would be times 2, but to get the negative, we'd have to multiply by negative 2. And then when we multiply, we'll get positive 16, negative 32. So it looks like our rule is times a negative 2. So this is going to be positive 64, negative 128, positive 256, negative 512. Our last sequence, this is interesting, 0, 1, 0, third, 0, fifth. Well, we can say for sure that it starts at 0, and it looks like every other term is 0. And these are all fractions. Let's make 1 into a fraction. Okay, so now the denominators are going 1, 3, 5, 7, 9. So I think this is 1 over 7. Now this rule, I think, is a little trickier. And let's take a look at it from this standpoint. If 0 is a term, and 1 over 1 is a term, and 0 is a term, then we can number the terms starting at the beginning. So we could say this is the first term, or term number 1, the second term, or term number 2, and then term number 3, number 4, number 5, number 6, 7, 8, 9, and term number 10. Well, what I'm noticing first of all is that all the zeros happen to be related to odd number terms. So we might say if term number is odd, then the term is equal to 0. And then it looks like all the even numbered terms, 2, 4, 6, 8, it appears that those are all the fractions. And what I see is that the numerator is always 1. And is there a relationship between the denominator and the term number? Do you see a pattern between the denominator and the term number? Well, this is what I'm noticing. If the term number is even, then the term equals 1 divided by, this number is always 1 less than the term number, 1 less than the term number. So term number minus 1. And I think that does it.